Okay, good afternoon, and here once more in North Carolina at the Harrah Hotel, 16th floor, and we're going to be displaying now the direct coupled output push-pull amplifier and its waveform. Now this amplifier was previously done in Decatur, Georgia, but for some reason a malfunction prevented the video from being displayed. So here are once more with the direct coupled output push-pull amplifier and its waveform. And here we have here now the amplifier, which is transistor 1 in this region and I collector 1 in this region, I base 1 and I emitter 1. And here we have now the current I collector 1, I collector 2 current, and this is the resistance load coming here and its corresponding voltage output load right in this region. Notice that the turns on this transformer is a 1-to-1 in both cases, 1-to-1, and here on the transistor 2 we have inductance transformer here with I base 2, I emitter 2 coming down, I collector 2, and the VCC, voltage collector. Now in order to provide the maximum power to the load resistor, see here we have the load resistor here, R subscript L, standing for R load. In order to provide the maximum power to the load resistor, we must supply the load with the maximum possible current. And such that now in the equation here now, P load maximum would be equal to half I squared R times the R load. And that would be equal to half I squared times 10, which is equal to 5 watts in power. And given now that the maximum supply current is 1 amps and that the resistant load is 10 ohms. And over here we have the voltage load waveform corresponding to this direct coupled output push-pull amplifier. And here we have now the input source with respect to time. And this is the waveform, a sinusoidal waveform. And I base 1 time, which is corresponding waveform here. And note here that in this region we have the transistor 1, which is this transistor here, over here, is on. And in this region, the transistor 2 is off. And this is transistor 2 here, transistor 1. While in this demonstration here with IB2 and IB2 of time, we have in this region here that the transistor 2 is on and the transistor 1 is off in this region. But this is to be omitted, and last of all we have now the I load of time. Here is the load here, the load resistor and the load voltage load. I load of time now would be this waveform. So once again we stress now that in order to provide the maximum power to the load resistor, we must supply the load with the maximum possible current, whereby P load maximum is equal to half I squared 1 I times the load resistor, which is equal to 1/2 1 squared, and 1 squared is 1, times 10, and that is equal to 5 watts. And this is a specific example here. And given that the maximum supply current is equal to 1 amps and that the resistance load is equal to 10 ohms. So that's a brief demonstration of the direct coupled output push-pull amplifier and its waveform. And here we have the short video in North Carolina, 16th floor at the Harrah Hotel. So we'll take another brief break, and then we'll return with our final session with our calculus made simple.